Hello friends, now we will start the new topic, that is methods of integration. In this video, I will explain all the details of the method of substitution and exercise 7.2. Therefore, this video will be the biggest video. Okay, now let us start. Methods of integration. In previous section, we discussed integrals of those functions which were readily obtainable from derivatives of some functions. Okay. For example, we know the derivative of ddx of x raised to n plus 1 upon n plus 1. It's a derivative x raised to n, and hence the integral of x raised to n is x raised to n plus 1 upon n plus 1. It means that we know the derivative of x raised to n plus 1 upon n plus 1, and hence its integration of x raised to n is x raised to n plus 1 upon n plus 1. ddx of x is 1, and hence integral of 1 is x. Okay. ddx of sin x is cos x, and hence integral of cos x is sin x. All these are obtained from the standard list of the derivatives of the function. I had already explained in my previous video for the exercise 7.1. Okay, this is by the inspection directly. Okay, we can find out with the help of the derivatives. This method, it was based on inspection, that is on the search of a function f whose derivative is a small f, which led us to integral of f. Okay. However, this method, which depends on inspection, is not very suitable for many functions. Hence, we need to develop additional techniques or methods for finding integrals by reducing them into standard form. Which are the standard form? These are the standard form. Take the suitable substitution and reduce it to the standard form. Prominent among them are methods based on, first is integration by substitution, integration by using partial fraction, and integration by parts. And now in this video, we will discuss integration by substitution. Okay. In this section, we consider the method of integration by substitution. The given integral, that is integral f of x dx, can be transformed into another form by changing independent variable x to t. Okay. By substituting x is equals to g of t. Okay. Now consider here the integral I is equals to integral f of x dx. Put x is equals to g of t, so that if we differentiate this with respect to t, then here you will get ddx ddt of is equals to g dash of t. Then what is the dx is equals to? Dx is equals to g dash t into dt. Substitute the value of dx here. Substitute the value of x, which is the g of t, and hence the integral is changed to the variable t in this way. Okay. This change of variable formula is one of the important tools available to us in the name of integration by substitution. It is often important to guess what will be the useful substitution. Usually, we make a substitution for a function whose derivative also occurs in integrand, and I will explain you. In each and every examples, there is a function and its derivative is also present there, but you have to select the proper substitution as illustrated in the following example. Now the first example, see this here. integrate the following functions with respect to x. Okay. First, I will write I is equals to, I is equals to integral sine of mx into dx. We know the integral of sine x. It's a minus cos x plus c. But we don't know the integral of sine of mx. And so that we will reduce this mx to a single variable. And here dx is also present there derivative. And therefore, here I will write here put mx is equals to t. Now differentiate on both sides. M is a constant, and therefore here you will dx is equals to dt. Always we find out the value of dx in each integral. And here what will the value of this dx? Therefore dx is equals to dt upon m. Okay, and this is very important for each integration. Okay, this dx is equals to dt upon m. Now substitute the value of this dx in above integration and it will turn like this. Therefore, this I is equals to integral sine of mx. What is the mx? M is a t. And therefore, I will write here sine t. And what is the value of this dx? Dx is dt upon m. It's dt upon m. And m is a constant. Take it outside the integral sign. And therefore, here you will have sine of t into dt. But what is the integral of sine t? It's a minus cos t. Therefore, it is a minus 1 upon m cos t, okay, and plus c. Now resubstitute the value of t, okay, and therefore here I is equals to minus 1 upon m the cos t, okay, resubstitute the value of t. Substitute the value of t. T is equals to mx plus c, and this way we can okay, is by the method of substitution. Okay, now we see the next example. Now the second example, here we first write I is equals to, okay, I is equals to integral sine 2x in bracket x, 2x sine of in bracket x square plus 1 into dx. Then what will be the substitution here? You can see there x square, okay, x square plus 1. But what is the derivative of x square plus 1? Its a derivative is a 2x. And hence, if we take the substitution x square plus 1 as a d, then this integral will be reduced to the standard form. Now, we'll take the substitution. Put x square plus 1 is equals to t. Okay. Now, differentiate this with respect to t, and the derivative of x square is a 2x into dx is equals to dt. Yes, I've got it. Now, see this here. I will write here 2x into dx is equals to dt. And how it is? See this here. This is very important. Once you get this idea, then your integral will be reduced to the standard form. Now see this here. This is the 2x into dx. Okay. And therefore, your integral will be I is equals to integral. This 2x into dx is dt. And here sine of t into dt. And therefore, its integral is minus cos t plus c. Okay. Now resubstitute the value of t. What is that? I is equals to minus cos of t. What is a t? T is a x square plus 1 plus c. Okay. And this is the answer. Now the next problem. Now the next problem is, I will write here, I is equals to integral tan of root x raised to 4 into sec square root x. Okay. And this divided by root x into dx. Now here the function is present there. Which is the function? Tan. What about its derivative? Sec square. Okay. No problem. Therefore the proper substitution is, we'll write here, put, this is the tan, here is the sec square. Okay. Put tan of root x is equals to t, and therefore after the differentiating you will get here sec square root x, and the derivative of root x is 2 root x into dx is equals to dt. But here we required sec square root x upon root x. Therefore transfer this 2 to the right hand side, and here you will get correct value. Okay. Sec square root x upon this root x into dx is equals to 2 dt. This is important now. Once you know this, your integral will be very easy. Now see this, your integral I is equals to sec square root x upon root x into dx. This total frame will be changed. This, okay, this whole will be the change to 2 dt. Okay, and see this here, integral tan of root x, its value is a t. Therefore here tan of it, tan raised to 4 root x. Therefore here it is a 4, and here dt upon 2 dt, it is a 2 dt. Again this can be written as integral t raised to 4 into dt, and therefore 2 t raised to 4 means what? Here t raised to 5 upon 5 plus c, and resubstitute the value of t. Here 2 by 5. What is the t? T is a tan of root x, but its power is a 5. Therefore, tan of root x, tan raised to 5 root x plus c. And this is the answer. This way, the function is present there. Also, at the same time, its a derivative is also there. Now we'll see the next example. Now the next example, first we'll write I is equals to integral sine of tan inverse of x upon 1 plus x square into dx. If we observe this integrand, here the tan inverse of x and its derivative is a 1 plus x, 1 upon 1 plus x square. And therefore here we will take the substitution. Tan inverse of x is t, and then here you will get only the sine t. See this here. Put tan inverse of x is equals to t, and therefore its a derivative is 1 upon 1 plus x square into dx, and that's equals to dt. And hence we can write here dx upon 1 plus x square is equals to dt. Okay. Now, this is the important. How it is? Dx upon 1 plus x square. And hence our integral. Okay. Our integral I is equals to, will change sine of tan inverse of x means what? Here sine of t. And what is the value of dx upon 1 plus x square? It is a dt, and hence this is the dt. And overall its integral is a minus cos t plus c, and this is I. Therefore, I is equals to minus cos of, what is the t? T is a tan inverse of x. Okay. And it's a plus c. Answer. That is what is the answer? I is equals to minus cos of tan inverse of x plus c. It means that we always transfer this integral to the standard result. See this here. This is the standard result that we have seen in our first video for the exercise 7.1. Okay. Now the next example. Now we discuss some important integrals involving trigonometric functions and their standard integrals using substitution technique. These will be used later without a reference. Now we know the derivative of sin x is a cos x. Okay, we know the derivative of sin x is a cos x, and hence the integral of cos x is a sin x. But in case of the tan x, whose derivative is a tan x? It is not possible directly, and for that we are finding some standard results for the trigonometric functions. For example, the integral of the tan x. Okay, this is the first one. Now here we will find out the integral of tan x. We can't find it directly because we don't know that who's the derivative. Okay, we don't know. Here is a function whose derivative is a tan x. Okay, which is the function whose derivative is a tan x? Yes, from the integral. Now I will say that is a ddx of log of sec x is a tan x. How it is? What is the derivative of log of sec x? Is a 1 upon sec x into derivative of sec x is a sec x into tan x, and this sec x is cancelled. You will get here tan of x is equals to tan of x, and in this way, and hence the integral of tan x is log of sec x. For that, we will find out how the integral of tan of x is a log of sec x with the help of method of substitution. Okay, now see this here. First, I is equals to integral tan of x into dx, and that's equals to integral sin x upon cos x into dx. Again here, with the help of the method of substitution, here the function is present, its derivative is also present. Then what will the proper substitution? Here we take the cos of x is equals to t. Put cos of x is equals to t, differentiate it with respect to x, and therefore here you will get minus sin x into dx is equals to dt, and therefore sin x into dx is equals to minus dt. Okay, and this is the important. Here that is a sin x into dx, that will be the minus dt. Therefore our integral, this is the integral, and it will be transferred to first is a minus dt, and what is here? Cos of x, it is a t, and therefore minus integral dt upon t. We know the standard result. The derivative of log of x is 1 upon x, and hence the integral of 1 upon x is log x. With the help of that, the integral of dt upon t is minus log t, and here plus c. Again we will absorb here the negative sign. If we absorb it, then you will get here log of here 1 upon t with the rules of logarithm, and resubstitute the value of t here, the 1 upon t. What is the t? T is a cos x, resubstitute the value of plus c. But what is the reciprocal of cos x? Is a sec x, and hence this is the log of sec x plus c, and hence integral of, what is that? Integral of tan of x into dx is equals to log of sec x plus c, and this is the answer. Integral of tan of x into dx is equals to log of sec x plus c. Now the next example. Now the next is a integral of cot of x into dx is equals to log of mod of sin x. If anyone asks you that is whose derivative is cot x. It is not easy, and therefore again here we will use the method of substitution to find out the integral of cot x. Okay. Yes. The I is equals to integral cot of x into dx, and this equals to integral cot. Cot means what? Cos of x upon sin of x into dx. Now put the substitution. It's very clear that here the function is present, its derivative is present. Which is the function? We take here function sin x, and its derivative is cos x. Put sin x is equals to t. Therefore, its derivative is cos of x into dx, and that's equals to dt. Okay. Therefore, the cos of x into dx is equals to dt. Here cos of x into dx is equals to dt, and this integral can be written as I is equals to integral cos of x upon sin of x into dx. Cos of x into dx, which is the dt, its value is dt, and here 1 upon sin x. But what is the sin x? Sin x is a t, and hence I is equals to integral dt upon t. Therefore, its integral is a log of mod of t plus c. Now resubstitute the value of t, log of mod of t. What is the t? T is a sin x, mod complete, and plus c, and hence integral of cot x into dx is equals to log of mod of sin x plus c. Okay. Now the next problem. Now the next question. Now again, my question is that which is the function whose derivative is a sec x, and then the integral of this sec x will be that function. Okay, but for this we can't say directly, and hence we apply here the special method by using the substitution. Now see this here. I is equals to integral sec x dx, and for this here we multiplied numerator and the denominator by sec x plus tan x. Okay, and here the denominator in bracket sec x plus tan x into dx. Now after multiplication here sec x into sec x, here you will get sec square x plus sec x into tan x, tan x into sec x, and this divided by sec x plus tan x. Okay. Now here the substitution again. Function is present and its derivative is also present. Which will be the function here? Sec x plus tan x is a function. The derivative of sec x is a sec x into tan x, that is a tan x into sec x, and the derivative of tan x is a sec square. And hence we put sec x plus tan x is equals to t. Derivative of sec x is a sec x into tan x, sec x into tan x. Derivative of tan x is a sec square x. Okay, and this bracket is completed into dx, and this equals to d. Okay, this is the important. Therefore, our integral this changes to I is equals to integral. The value of sec square x plus tan x into sec x into dx, that whole is equals to dt upon t. Now what is the integral of 1 upon t? It is a log of t. Log of mod of t plus c. Okay, and therefore the answer is I is equals to integral of sec x into dx is equals to log of mod of sec x plus tan x mod complete plus c. This is the this way we can find out the integral of sec x. Now next again the integral of cosec x into dx is equals to log of mod of cosec x minus cot x. Again my question is that which is the function whose derivative is cosec x? Okay, you can't tell directly this function, and hence if we integrate it on both sides, integral and derivative will get cancelled, and here you will get the integral of this cosec x into dx is equals to that f of x. And that's why again here we are applying the method of substitution to find the integral of cosec x. Again here I is equals to integral cosec x into dx. Now note this step. What is that? Multiplied numerator and the denominator by cosec x minus cot x. Okay. Now keep this cosec x into in bracket cosec x minus cot x upon cosec x minus cot x bracket complete into dx. Then simplify this. Cosec x into cosec x, you will get here cosec square x minus cosec x into cot x, and this divided by cosec x minus cot x into dx. Again here the substitution. What is that? Put. Here the function is present. Which is the function? Cosec x. Its a derivative is a minus cosec x into cot x. Cot x is also present. Derivative is a minus cosec square x. Means that is a minus. The derivative of minus cot x is a cosec square x. Therefore, we will substitute here. Put cosec x minus cot x is equals to t, and therefore its a derivative is minus cosec x into cot x plus cosec square bracket complete into dx is equals to dt, and therefore here if we rearrange the terms, that is a cosec square x minus cosec x into cot x bracket complete into dx, and that's equals to dt. Okay, now this is the important, therefore this bracket. Now see this here, our integral I is equals to, this is the cosec square x minus cosec x into cot x upon cosec x minus cot x into dx will change. The value of this cosec square x minus cosec x into cot x into dx, that's nothing but the dt, and cosec x minus cot x is a t, and therefore its answer is a log of mod of t plus c, and therefore the answer is a log of, what is a t? T is a cosec x minus cot x. Cosec x minus cot x mod and plus sine, and hence the answer, what is that? The integral of cosec x into dx is equals to log of cosec x minus cot x plus t. You can see this again. Now the next, find the following integrals. Integral of sine cube x into cos square x dx. Okay. Now here we want to rearrange the terms. Then we will get the proper substitution. What is that? See this here. Integral sine cube x into cos square x into dx. If I take this one sine x here, then there will be the sine square x into cos square x. If I replace this sine square x by the identity 1 minus cos square x into cos square x into sin x into dx. Now here the function is present, its a derivative is also present. Which is the function? Cos of x is a function, its a derivative is a minus sin x. We can arrange its a negative sign. Put t is equals to cos x, so that it's a derivative dt is equals to minus sin of x into dx. Okay, and hence we will write here, but we require here sin x into dx, and therefore the have sin x into dx that is equals to minus dt. Okay, this is important. Therefore, here our integral will change. That is the integral. Here is a minus sign. Okay, sin x into dx that's equals to minus dt. That's why here we have taken minus sign. Next, 1 minus cos square x. Cos of x is t. Therefore, it is a 1 minus t square. Again cos square x. Therefore, it is a t square into dt. Okay. Next simplification is a this t square into 1 t square. T square into t square t raised to 4. Here is a minus sign. Its integral is a t raised to 3 upon 3, 3 raised to 5 upon 5 plus c. If you open the bracket and resubstitute the value of t, which is the cos x. Therefore, if you open the bracket, the sign will change minus and plus, and resubstitute the value. It's a cos cube x plus 1 upon 5 cos of x raised to 5 plus c, and this is the answer. Okay. Now the next is a integral sin x upon sin of x plus a into dx. Now see this here. What will be the substitution? Here put the substitution. X plus a is equals to t. It implies that the derivative of x dx is equals to dt. At the same time, the value of x is equals to t minus a. These are important. The value of dx and the value of dx is dt and the x is t minus a. Now see this here, our integral sin x upon sin of x plus a into dx. Substitute the x, which is the t minus a. X plus a is the t. Dx is dt. Okay. Now integral sin of t minus a, that is the expansion of sin of a minus b. What's the sin a minus b? We know the formula. Here I will write here again. Sin of a plus or minus b, and that's equals to sin a cos b plus or minus cos a sin b. Okay. Now expand this. Sin t cos a minus cos t sin a. Next, split up this. If we split up this, means what? Sin t into cos a upon sin t will get cancelled. It means that here you will get integral sin of t in bracket sin t into cos of a upon sin t minus cos t into sin of a upon sin t bracket complete into dt. Sin t will get cancelled, and here you will get integral in bracket cos of a minus here cos t upon sin t, and that will be the cot t. First I will write here constant sin a into cot of t bracket complete into t. Cos of a is a constant, take here cos of a into dt, minus sin of a, it's a constant, integral of cot of t into dt. What is the integral of dt? Is t minus sin of a as it is. Cot of t, its integral is a log of sin of t plus c, and hence the answer integral of sin x upon sin of x plus a is equals to into dx is equals to x cos a minus sin a log of mod of t. Substitute the value of t, which is the x plus a. Okay, let's see and this is the answer. You can see this here. Now next problem. Integral of 1 upon 1 plus tan x into dx. Now here we don't know this type of the integration in the standard form, but if we rearrange the terms like this here, integral dx upon 1 plus tan x means what? If I write here, I is equals to integral 1 upon 1 plus tan x. Again, it can be written as 1 upon 1 plus tan x means what? Sin x upon cos x. And if we simplify this, then what you will get here? This is dx, dx, dx. Here you will get cos x plus sin x upon cos x. And if you multiply and reciprocal, you will get here cos x into dx upon cos x plus sin x. Next, here one more arrangement. We can arrange this numerator just like the denominator. How it is? Already there cos of x is present there. We can write here cos of x plus cos of x means what? 2 times cos of x. But we have only 1 cos x. That's why we have arranged here 1 upon 2. That 2 will get cancelled. First, cos of x plus cos of x, you will get 2 times cos of a. You can cancel this 2, you will get this original form. Next, also we have added here plus sin x and minus sin x. Plus sin x minus sin x get cancelled. Cos x plus cos x, 2 cos x, 2 to get cancelled. And here we have arranged to find out this integral. Now split up this, separate this. If we separate this cos x plus sin x upon cos x plus sin x, you will get here 1. Okay, here is the 1 into dx. And next is a cos x minus sin x upon cos x plus sin x. Okay, 1 upon 2 integral separated cos x minus sin x upon cos x plus sin x. Okay, now what about this integral of this 1? Integral of this 1 dx is x. It's 1 upon 2 plus 1 upon 2. See this here term cos x minus sin x upon cos x plus sin x. If we substitute here the cos x plus sin x as a t, so that it's a derivative. Derivative of sin x is a cos x and derivative of cos x is a minus sin x. Bracket complete into dx is equals to dt. And that's why we can solve this integration with the method of substitution, taking the substitution cos x plus sin x is equals to t. And here that integral we change is like this, x upon 2 plus 1 upon 2 integral 1 upon t into dt. And hence x upon 2 plus 1 upon 2 log of mod of t plus c. Resubstitute the value of the t, that is here. You will get x upon 2 plus 1 upon 2 log of mod of, what is here? Cos x plus sin x mod complete plus c. This is the answer. Okay. In this way, we have completed all the short examples. Now we will start the exercise 7.2. Okay, the first example. Now here the first example. I is equals to integral 2x upon 1 plus x square into dx. Here the function is present, its derivative is also present. Therefore, put 1 plus x square is equals to t. derivative of 1 plus x square is a 2x, and that's why we get here 2x into dx is equals to dt. We have got it, and therefore our integral I is equals to integral 2x into dx, that is a dt, upon 1 plus x square, it is a t, and therefore I is equals to integral dt upon t. Its integral is a log of mod of t plus c. Resubstitute the value of t, which is the log of mod of. What is a t? T is a 1 plus x square mod complete plus c, and this is the answer. Okay. Now the next problem. Now the next example is a I is equals to integral in bracket log of x bracket square upon x into dx. Here the function is present and its derivative is also there. Which is the function? Log of x is t, and its derivative is 1 upon x. Therefore, we have the substitution. Put log of x is equals to t. Therefore, its derivative 1 upon x into dx is equals to dt. That is a dx upon x, and this will be important. Dx upon 1 upon x. 1 upon x into dx is equals to dt, and therefore our integral changes. I is equals to integral log of x, which is a t. Therefore, it is a t square dx upon x, and is a dt. Now, what is the integral of t square? It is a t raised to 3 upon 3 plus c, and therefore here I is equals to t cube upon 3 plus c. Resubstitute the value of t. What is t? T is a log x upon 3, that is a log of x bracket is to 3 plus c, and therefore t. Answer is log of x upon 3, log of x bracket is to 3 upon 3 plus c. Now the next example. Next integral 1 upon x plus x into log x. Okay. We can write this integral. I is equals to integral dx upon x plus x log x. We can take x as a common. Integral dx upon x in bracket 1 plus log x bracket complete. And here we have the substitution. Put 1 plus log of x is equals to t, and it's a differentiation. Derivative of 1 is 0, which is a constant, and the log of x is a 1 upon x into dx, and this equals to dt. This is the important. 1 upon x into dx is equals to dt. Yes, sir. Dx upon x, that's a dt. Therefore, our integral I is equals to will change dx upon x, which is the dt, and 1 plus log x. 1 plus log x is a t. Its integral is a log of mod of t plus c. This is a, and therefore I is equals to log of mod of t means what? 1 plus log x, 1 plus log x, bracket complete, plus c, and hence the answer I is equals to log of mod of 1 plus log x mod complete plus c. Okay, and this is the answer. See this. Now the next problem. Next integration. I is equals to integral sin x into sin of cos x into dx. Now the substitution. Here the function is a present, which is the substitution cos x. If you substitute cos x, its derivative is also there, minus sin x. We can arrange its negative sign. Put cos x is equals to t, and therefore its a derivative minus sin x into dx is equals to dt. But we have sin x into dx, and therefore we can write it sin x into dx, and that's equals to minus dt. Okay, minus sin minus dt, and this is the important. Once you get sin x into dx minus dt, our problem is easy. Therefore, our integral, this is equals to I is equals to integral sin x into dx, that is a minus dt, and this is the sin cos x is t. Therefore, I will write here sin of t in bracket minus dt minus sin t into dt. Its integral is equals to minus in bracket minus cos t plus c. This minus and minus, that will become plus, and therefore here you will get plus cos of t plus c, and hence I is equals to cos of, but what is t? T is a cos x. Cos x bracket complete plus c. Therefore, the integral is a cos of cos x plus c. This is the answer. Next problem. Next integration is I is equals to integral sine of ax plus b into cos of ax plus b into dx. You can solve this integral in two ways. The first way is like this. Put here substitution. Sine of ax plus b is equals to t. Its derivative is what is that? Cos of ax plus b, okay, into derivative of ax plus b is a. I will write here, into this dx is equals to dt. Okay, and therefore cos of ax plus b into dx is equals to dt. This is the first. Okay, that is the cos of ax plus b into dx is equals to dt. Therefore, our integral will change like this. What is that? Cos of ax plus b into dx. Its value is dt upon a here. Okay. And sine of ax plus b, that is directly t. And here t into dt upon a. Now the integral of this is a t square upon 2a. Its integral is a t square upon 2a plus c. Resubstitute the value of t, which is the sine square in bracket ax plus b, this divided by 2a plus c, and this is the also one type of substitution, and you will get the answer. Okay. Now, what about the next part? You can arrange the terms. Sine of ax plus b into cos of ax plus b is equals to, okay, and we can arrange here 2 upon 2 sine of ax plus b into cos of ax plus b. That is 2 times sine theta into cos theta, and this is nothing but sine of 2 theta means what? Sine of 2 in bracket ax plus b, and we can find out the integral of this. That is our integral I is equals to sine of ax plus b into cos of ax plus b into dx, and this equals to, this is equals to 1 upon 2. It's a value sine of in bracket 2 ax plus b bracket complete into dx. How to solve this integral? We have the substitution. Put 2 in bracket ax plus b is equals to t, and therefore it's a differentiation. 2a derivative of x is dx. Okay, 2 is multiplied constant. 2b, it's a constant, its derivative is a 0. This is the dt, and we required only the dx. Therefore, we can write here dx is equals to dt upon 2a. Okay, dx is equals to dt upon 2a. And this is the important. Now substitute the values here. Here 1 upon 2 integral sine of t dx is dt upon 2a. dt upon 2a. Overall, this integral can be written as 1 upon 2a into a 2, that is 4a, integral of sine t into dt, and this equals to 1 upon 4a minus cos of t plus c, and therefore I is equals to minus 1 upon 4a cos of 2 times cos of 2 times in bracket ax plus b plus c. Okay, and also answer. Therefore, we have the two answers. Once you can have this set of the answers, and here the another answer. Now the next problem. Next integral is I is equals to integral in root of ax plus b into dx. Therefore, the substitution, put ax plus b is equals to b, and therefore the derivative of constant b is a 0. A into dx is equals to dt, and therefore dx is equals to dt upon a. Okay, this is the important. Dx is equals to dt upon a. Therefore, our integral I is equals to integral in root of ax plus b into dx, and this equals to integral dx. The value of dx is dt, and ax plus b, it is a t, and therefore root t into dt upon a, and that's equals to 1 upon a into a root of t into dt. Therefore, its integral is a 1 upon a integral of root of t is a t raised to 3 by 2 upon 3 by 2 plus c, and therefore I is equals to 1 upon multiplied and reciprocal, you will get 2 by 3a e raised to 3 by 2 plus c. Resubstitute the value of t, which is the 2 upon 3a. What is the t? Ax plus b. Here ax plus b raised to 3 by 2 plus c, and this is the answer. Okay. You can see this. Now the next problem. Now for the next example, I is equals to integral x into in root of x plus 2 into dx. Now here again this substitution is important. Dx is present here. Derivative of x is dx. Therefore, the radicand is important. Put x plus 2 is equals to t. Therefore, it's a derivative of x is dx is equals to dt. And also one of the important value, x is equals to here. X is equals to t minus 2. Therefore, I will write here x is equals to t minus 2. These two are important. And hence, we have the two important values. Dx is equals to dt. And next is x is equals to t minus 2. Now we'll substitute these values here in our integral. Okay. Therefore, I is equals to integral x in root of x plus 2 into dx is equals to integral. But the first x is t minus 2. T minus 2 into root of x plus 2. Root of x plus 2 is nothing but root t into dt. And this equals to root t into t. T raised to 3 by 2. 2 into root t. Here t raised to 1 upon 2. This bracket is completed and into dt. Now the integral of t raised to 3 by 2. It is t raised to 5 by 2 upon 5 by 2 minus 2 into t raised to 1 upon 2 plus 1 means what? T raised to 3 by 2 upon 3 by 2 plus c. And after simplification, you will get 2 by 5 t raised to 5 by 2 minus 4 by 3 t raised to 3 by 2 plus c. Okay. Now, we substitute the value of t, and therefore our integral I is equals to 2 by 5. What is the t here? X plus 2. So we write here x plus 2 bracket is 2 5 by 2 minus 4 upon 3, and t raised to 3 by 2 means what? X plus 2 raised to 3 by 2 plus c. Okay, this is the answer. Okay. Bracket. And in this way, completed this. Now the next example. Now the next example. Here, I is equals to integral x into in the root of 1 plus 2x square into dx. Now what is substitution here? We can see here 1 plus 2x square, derivative of x square is a 2x, and it is present here. Therefore put here 1 plus 2x square is equals to t, and therefore the derivative of 1 is 0, 2x square is a 4x into dx is equals to dt, and hence x into dx is equals to dt upon 4. This is the first part, and which is the important one. Therefore our integral can be changed. It's like this. I is equals to integral x into dx is a dt by 4, and here in root of 1 plus 2x square, 1 plus 2x square is a t, and therefore here we have root t into dt upon 4. Now the integral of root of t is a t raised to 3 by 2 upon 3 by 2 into 1 upon 4 plus c. Of this again multiplied and reciprocal, you will get here 2 by 3 into 1 by 4 into t raised to 3 by 2 plus c, and overall you will get here 1 by 6 into t raised to 3 by 2 plus c. Resubstitute the value of t. What is a t? In bracket 1 plus 2x square and bracket raised to 3 by 2 plus c, and hence I is equals to 1 upon 6 in bracket 1 plus 2x square raised to 3 by 2 plus c. Okay, and now you can see this. These are very simple examples. We are solving these all the examples with the method of substitution. Now the next example, I is equals to integral in bracket 4x plus 2 and in root of x square plus x plus 1 into dx. Now what is one more thing is that here we can take 2 as a common from this and write here 2x plus 1. I have taken common, you can note this step, x square plus x plus 1, because the derivative of x square plus x plus 1 is a 2x plus 1, and that's why I have taken as common. Now this substitution, function is present there, x square plus x plus 1, its a derivative is here. Therefore, put x square plus x plus 1 is equals to t. Its a derivative is a derivative of x square is 2x, derivative of x is 1, bracket complete, into dx is equals to dt, and this we require here. Okay. This is the important. Once you get this, and our integral will be easiest one. Therefore, our integral, this I, can be written as I is equals to integral 2 in bracket 2x plus 1 in root of x square plus x plus 1 bracket complete into dx. Therefore, the value of 2x plus 1 into dx is dt, 2 dt, and here this is the root of t into dt. Integral of root t is equals to 2 into t raised to 3 by 2 upon 3 by 2, t raised to 3 by 2 upon 3 by 2 plus c, and therefore that is 2 into 2 upon 3 into t raised to 3 by 2 plus c, and that is equals to 4 upon 3 into t raised to 3 by 2 plus c. Now substitute the value of t, and that is a x square plus x plus 1. Therefore, I is equals to 4 upon 3 in bracket x square plus x plus 1 bracket is to 3 by 2 plus c. Okay, and this is the answer. And we can write this. Next example. Now the next question is I is equals to integral dx upon x minus root x. Now see this is a very nice problem, and what will be the substitution, and its a derivative is also present there, and for that we can take here the root x is common from the denominator. Therefore 1 upon root x into this dx upon in bracket root x minus 1 bracket complete. Now this substitution, what is the substitution? Now here the function is present, its the derivative is also there. What is that? Root x is there, derivative of root x is 1 upon 2 times root x. Therefore put root x minus 1 is equals to t, and it's a derivative. What's the derivative of root of x minus 1? Here 1 upon 2 times root x into dx is equals to dt. Means what? Dx upon derivative of root x is 2 times root x is equals to dt. And again, the value of dx upon root x, I require this value dx upon root x, that is equals to 2 dt. This is the important. Therefore, this integral I, integral 1 upon root x into dx upon root x minus 1, we change. I will write this integral again. Integral of 1 upon root x into dx upon, in bracket, root x minus 1, change like this. Dx upon root x is 2 dt. Okay, it is 2 dt. And what is the value of root x minus 1? It's a t. Okay, therefore 2 integral dt upon t, and its integral is a standard result, that is a 2 times log of mod of t plus c. Okay, now resubstitute the value of t, that is a 2 times log of mod of, what is that? T is a root x minus 1 mod complete plus c. This is the I is equals to. Okay, and therefore I is equals to 2 log of mod of root x minus 1 plus c. This is the answer. See this once again. Now the next example. I is equals to integral x upon in root of x plus 4 into dx. Now here the substitution is very important. Put x plus 4 is equals to t. This is first one. Therefore, x is equals to, what is the value of x? X is a t minus 4. Okay. This is important. Value of t is important. X is important. Next, dx. Dx is equals to dt. Dx is equals to dt. And this is these two are important. Otherwise, the integral is very easy. Now see this here. I is equals to, I will write here, I is equals to integral x upon in root of x plus 4 into dx, and here integral, what about the x? X is t minus 4, t minus 4 upon the root of t, here the root of t, okay, into dt. Now separate this integral in bracket t upon root t minus 4 upon root t into dt. Okay. Now the separations, we can write it like this: integral t upon root t means what? We will get here root t minus 4 upon root t means what? 4 into t raised to minus 1 upon 2 bracket complete into dt. Okay. Now there integrations. Integral of root of t is t raised to 3 by 2 upon 3 by 2 minus 4. Integral of t raised to minus 1 upon 2 is t raised to minus 1 plus 1 means what? T raised to 1 upon 2 upon 1 upon 2 plus c. Now this is the multiplied and reciprocal, and then you will get here 2 by 3 into t raised to 3 by 2 minus, again multiply and reciprocal, 4 into 2, 8. It's 8 into t raised to 1 upon 2, and this is the plus c. Okay. And therefore, here we can resubstitute the value of t. Also, you can take t raised to 1 upon 2 as a common, and 2, that is here equals to, you can take 2 by 3 t raised to 1 upon 2 as a common, and then in bracket you will get here t minus, as you are taking 3, and here if you take 8 means what? 2 into 2 into 2, take 1 2 is a common, and again you are taking one more extra, therefore 4 into 3, and that will become 12 here plus c. Okay, and therefore our integral I is equals to 2 by 3 t raised to 1 upon 2 in bracket t minus 12 plus c. Replace the value of t. What is that? This I is equals to 2 by 3. What is the t? T is a x plus 4 upon raised to 1 upon 2. Means what? It is a root t. Again, you can write here 2 by 3. This is the root of t, and in bracket t minus 12 plus c. And that's why the answer is a root t. Root of t means what? A root of x plus 4 into the value of t is a x plus 4 minus 12 bracket complete plus c. And the final answer is here. This I is equals to 2 by 3 in root of x plus 4 in bracket x minus 8 plus c, and this is the answer. Okay, see this. Now the next problem. Now this is also Nice example. Then what will the substitution here? At x cube minus 1, that's equals to t. But its a derivative is x square, 3x square. X square is not present here. Therefore, x raised to 5 can be split up like this, x square into x cube. And hence, we write it as like this. I is equals to integral x cube minus 1 raised to 1 upon 3 into x raised to 3 into x square into dx. The substitution is put x cube minus 1 is equals to t. Therefore, it implies that, okay, it implies that x cube is equals to t plus 1. This is important. Okay. We required the value of x cube, and that is t plus 1. Next, as x cube is equals to t plus 1, therefore its a derivative is a 3x square into dx is equals to dt. Therefore, x square into dx is equals to dt upon 3. Okay. And again we will substitute this value. These are the two important values. Now see this, our integral I is equals to integral I is equals to integral, this integral we will take here, x cube minus 1, okay, bracket raised to 1 upon 3 x cube into x square into dx. Now substitute the values. X cube minus 1 as a t, therefore its integral is a t raised to 1 by 3. X cube is a t plus 1, here t plus 1. And the value of x square into dx is dt upon 3, and therefore overall take 1 by 3 as a common, and the simplification t raised to 1 by 3 into t means what? 1 by 3 plus 1, that is 4 by 3. First will be t raised to 4 by 3, and 1 into t raised to 1 by 3, it's a t raised to 1 upon 3, bracket complete, into dt. Now the integration. T raised to here 1 by 3. Its integral is a t raised to 4 by 3 plus 1 means what? T raised to 7 by 3 upon 7 by 3. And hence t raised to 7 by 3 upon 7 by 3 plus again 1 by 3 into the integral of t raised to 1 by 3. That is 1 by 3 plus 1. It's a 4 by 3 upon 4 by 3. These 3 will get cancelled. These 3 will get cancelled. And therefore you will get 1 by 7 t raised to 7 by 3 plus 1 by 4 t raised to 4 by 3. Therefore here I is equals to 1 upon 7 in bracket x cube minus 1 raised to 7 by 3 plus 1 by 4 into in bracket x cube minus 1 raised to 4 by 3 plus c, and this is answer. Okay. Now we'll take the next problem. Now the next problem, I is equals to integral x square upon, in bracket, 2 plus 3 x cube and bracket raised to 3. Now again here the substitution. Function is present and its derivative is also present. Means that derivative of x cube is a 3x square. Means what? We have here square term and into dx. Therefore the substitution, put t is equals to 2 plus 3x cube, okay, and therefore dt is equals to dt is equals to 9, derivative of 2 is 0, 9x square into dx, and hence x square into dx is equals to dt upon 9. Okay, this is important. This is the x square into dx is equals to dt upon 9. Therefore here I is equals to integral x square into dx upon 2 plus 3x cube bracket square, and this equals to, now what is a x square into dx? X square into dx is a dt upon 9, and this whole divided by, sorry, here t cube, t raised to 3. Therefore 1 upon 9 into integral dt upon t raised to 3, 1 upon 9 integral t raised to minus 3 dt, and therefore its integral is 1 upon 9, okay, t raised to minus 3 plus 1, it's a t raised to minus 2 upon minus 2, okay, and this equals to 1 upon minus 1 upon 18 t raised to minus 2. Okay. Therefore I is equals to minus 1 upon 18 into 1 upon t square. Resubstitute the value of t, you will get here I is equals to minus 1 upon 18 into 1 upon the t is a 2 plus 3 x cube and whole bracket square plus c plus c and plus c. This is the answer. Minus 1 upon 18, 1 upon 2 plus 3x cube plus 3 3x cube bracket square plus c. Answer. Now the next problem, example number 14. I is equals to integral 1 upon x in bracket log x bracket raised to m into dx. Okay. Now here again the function is there. Substitution. What is that? Log of x is equals to t. Its derivative is 1 upon x. And therefore, we put here, substitute here, put log of x is equals to t. It's a derivative. 1 upon x into dx is equals to dt. First one. Now our integral changes. I is equals to integral. The value of dx upon x is dt upon t raised to m, and therefore I is equals to integral t raised to minus m into dt. This equals to t raised to minus m plus 1 upon minus m plus 1 plus c. Okay. And hence resubstitute the value of t. What is a t? T is a log of x. It is a log of x bracket is to minus m plus 1 whole divided by in bracket minus m plus 1 plus c. Okay. It can be written as I is equals to 1 upon in bracket minus m plus 1 bracket complete into, so power will become plus. Therefore, log of x and bracket is to m minus 1 plus c. This is the answer. You can have both type of the answers. The first is like this, and this is the second one. Now we'll take the next example. Now the next integration is I is equals to integral x upon 9 minus 4x square into dx. Okay. Now the substitution here. The derivative of x square is a 2x, and we can have the proper substitution here. Put 9 minus 4x square is equals to t, and therefore it's a derivative of the constant is 0 minus 8x into dx is equals to dt. Therefore x into dx is equals to minus 1 upon 8 into dt. This is the first one. Therefore, our integral I is equals to integral x into dx is a minus 1 upon 8 into dt, and to the denominator 9 minus 4x square, it is a t. Therefore, I is equals to minus 1 upon 8 integral dt upon t, and that's equals to minus 1 upon 8 log of mod of t plus c, and therefore I is equals to minus 1 upon 8 log of mod of, what is a t? T is a 9 minus 4x square mod complete plus this is the answer. Next example is I is equals to integral e raised to 2x plus 3 into dx. Put 2x plus 3 is equals to t, and therefore 2 into dx is equals to dt. Therefore, dx is equals to dt upon 2. Okay. Dx is equals to dt upon 2. And therefore, our integral I is equals to integral e raised to 2x plus 3 is e raised to t. And what is the value of this dx? Dt upon 2. Therefore, its integral is a e raised to t upon 2 plus c. Therefore, I is equals to e raised to t upon 2 plus c. Substitute the value of t. What is that? 2x plus 3 e raised to 2x plus 3 upon 2 plus c. This will be answer. Now the next example. Next integration. I is equals to integral x upon e raised to x square. Okay. Into dx. Again, put here the substitution is, what is that? X square. Its derivative is a 2x. And therefore, put x square is equals to t. Its derivative is 2x into dx is equals to dt. Therefore, x into dx is equals to dt upon 2. Okay. And here x into dx upon 2, and therefore our integral I is equals to integral x dx is dt upon 2 upon e raised to t, and that's equals to 1 upon 2 e raised to minus t dt, and therefore its integral is 1 upon 2 e raised to minus t. Okay. Upon here minus 1 means what? Derivative of minus t is minus 1 or the coefficient of t. Okay. And here plus c. Therefore, resubstitute the value of t here minus 1 upon 2. Okay. This is the first. Second, make this power as a positive. Therefore, you will get e raised to t plus c. We substitute the value of t. I is equals to minus 1 upon 2, 1 upon e raised to t. And again here t is a x square plus c. Okay. This is the answer. Now the next example. Here the I is equals to integral e raised to tan inverse of x upon 1 plus x square into dx. Put here tan inverse of x, that's equals to e. Therefore, it's a derivative 1 upon 1 plus x square into dx is equals to dt. Okay. And this is the dx upon 1 plus x square. I have got it. This is important. Therefore, our integral I is equals to integral e raised to tan inverse of x means what? E raised to t dx upon 1 plus x square. It is dt. What is the integral of e raised to t? It is e raised to t plus c. Okay. And resubstitute the value of t. Therefore, I is equals to t. T is a tan inverse of x plus c. Next problem. Now the next problem, I is equals to integral e raised to 2x minus 1 upon e raised to 2x minus 1 into dx. Here we do not have the function and it's a derivative. And that's why here we'll divide numerator and the denominator by e raised to x. Therefore, here e raised to 2x minus 1 is divided by e raised to x upon e raised to 2x. Another sign is a plus sign. Denominator has the plus sign e raised to 2x plus 1 upon e raised to x and into dx. This equals to integral e raised to 2x minus 1 upon split of this, and then you will get here e raised to 2x upon e raised to x, you will get e raised to x, 1 upon e raised to x minus e raised to minus x upon e raised to 2x upon e raised to x, you get here e raised to x minus plus e raised to again minus x into dx. Now the substitution I is equals to, what is the substitution? E raised to x plus e raised to minus x is equals to t. Put e raised to x plus e raised to minus x is equals to t, and therefore the derivative of e raised to x is e raised to x, e raised to minus x is a minus e raised to minus x, here bracket complete, into dx, and that's equals to dt. Okay, and this is the important square bracket here. Next, our integral then change. I is equals to, see this here, e raised to x minus e raised to minus x, it's a changes to dt, and e raised to x plus e raised to minus x, it's the upon t. Okay, its integral is a log of mod of t plus c, and therefore I is equals to log of mod of e raised to x plus e raised to minus x mod complete plus c. Okay, this is the answer. Okay, now the next example, I is equals to integral e raised to 2x minus e raised to minus 2x upon e raised to 2x plus e raised to minus 2x into dx. Put here e raised to 2x plus e raised to minus 2x, and that's equals to t. It's a derivative is e raised to 2x into derivative of 2x is 2. Next, plus e raised to derivative of e raised to minus 2x is a minus 2x into derivative of minus 2x is a minus 2, and this bracket is completed into dx is equals to dt, and hence we can take 2 as a common, that is 2 in bracket e raised to 2x minus e raised to minus 2x bracket complete into dx is equals to dt, and hence e raised to 2x minus e raised to minus 2x, this bracket is completed into dx is equals to dt upon 2. Okay, this is the value, and it's again this square bracket here. This is the important value. Therefore, our integral is I is equals to integral e raised to 2x minus e raised to minus 2x into dx is the dt upon 2 upon to the denominator t is equals to 1 upon 2 integral dt upon t, and hence I is equals to 1 upon 2 log of mod of t plus c. Therefore, I is equals to 1 upon 2 log of mod of. What's the value of t? It's a e raised to 2x plus e raised to minus 2x mod complete plus c. The answer. Here I is equals to integral tan square in bracket 2x minus 3 into dx. Now again the substitution, 2x minus 3 is t. Put 2x minus 3 is equals to t, and therefore 2 dx. Okay. 2 dx is equals to dt, and hence dx is equals to dt upon 2. This is important. First. Therefore, our integral I is equals to tan square t into dx. The value of dx is a dt upon 2. Okay, and hence this I is equals to 1 upon 2 integral tan square t into dt 1 upon 2 integral. Now by using the identity 1 tan square x plus 1 is equals to sec square. Therefore, the value of tan square t is a sec square t and this. Now the integral of here I is equals to 1 upon 2 integral of sec square t is tan t, and the integral of this minus 1 is a t bracket complete and plus c1. I am writing here c, and therefore I is equals to integral 1 upon 2 bracket tan of t. Substitute the value of t, which is the 2x minus 3, 2x minus 3. Okay, again multiply this minus 1 upon 2 in bracket 2x minus 3 bracket complete plus c1, and next simplification 1 upon 2 tan of 2x minus 3. If you simplify it, then you will get minus x plus, I will treat as c1, it's a 3 by 2 plus c1, and overall it's a integral is 1 upon 2 tan of 2x minus 3 is the minus x plus c. Okay, the answer. Where I will write here, where c is equals to 3 by 2 plus c1. Okay. Now the next example, I is equals to integral x square 7 minus 4x into dx. Again put here 7 minus 4x is equals to t, and it's clear that minus 4 derivative of 7 is 0 and dx is equals to dt, and therefore dx is equals to minus dt upon 4. Important. Next, within here I is equals to, our integral changes to I is equals to integral x square 7 minus 4x, it's x square t, and the value of dx is minus dt upon 4. Okay, and minus 1 by 4 integral x square t into dt. What is the integral of x square t? Is a tan t minus 1 by 4 tan t plus c, and this is the I is equals to. Okay, and therefore I will write the answer. I is equals to minus 1 by 4 tan of 7 minus 4x plus c. Okay, the answer. Now next problem. I is equals to integral sin inverse of x upon in root of 1 minus x square into dx, and therefore put sin inverse of x is equals to p. Therefore its derivative is 1 upon in root of 1 minus x square into dx is equals to dt. Okay, therefore our integral changes to I is equals to integral sin inverse of x, it's a t, dx upon root of 1 minus x square is a dt, the t into dt, and therefore its integral is a e square upon 2 plus c, and hence I is equals to, what is the t? Now substitute the value of t, it is a sine inverse of t bracket square upon 2 plus c. Okay, and this is the answer. Now the next problem. Now the next question. I is equals to integral 2 cos x minus 3 sin x upon 6 cos x plus 4 sin x into dx. Now what is substitution here? This is here the denominator. We can take 2 as a common first of all. Therefore I is equals to integral 2 cos x minus 3 sin x upon, take 2 as a common, then in bracket you will get 3 cos x plus 2 sin x bracket complete into dx. Okay, put 3 cos x plus 2 sin x is equals to p. We find out its a derivative, then the derivative of cos x is a minus sin x, and hence here you will get minus 3 sin x plus derivative of sin x is a cos x, which is the 2 cos x bracket complete into dx is equals to dt. Okay, and hence this will be important. We get the numerator here. Minus 3 sin x plus 2 cos x bracket complete into dx is dt. Therefore, our integral I is equals to integral, what is that? 2 cos x minus 3 sin x. Okay, 2 cos x minus 3 sin x upon, okay, 2 in bracket 3 cos x plus 2 sin x bracket complete into dx. Now the value of minus 3 sin x plus 2 cos x is dt. Therefore I is equals to integral dt upon 2t, 1 upon 2 integral dt upon t. Okay, now its integral is a 1 upon 2 log of mod of t plus c. Okay, and hence I is equals to 1 upon 2 log of mod of 3 cos x plus 2 sin x mod complete. Okay, and plus c. This is the answer. You can see this. Next, I is equals to integral dx upon cos square x in bracket 1 minus tan x, it's the bracket square. Okay, now this can be written as I is equals to integral 1 upon cos square, that will become sec square x into dx upon 1 minus tan x, it's the bracket square, and dx. Okay, now the derivative of tan x is sec square x, therefore the substitution is put 1 minus tan x is equals to t, therefore it's a derivative minus sec square x into dx is equals to 1 minus tan x is equals to t, its derivative is a minus sec square x into dx is equals to dt, therefore sec square x into dx is equals to minus dt. Now substitute this in this integral. The value of sec square x into dx is minus dt upon t square. Take this t square to the numerator, power will become minus. Okay, and here is a minus sign, and the integral of t raised to minus 2 is a minus 1 upon t, and this minus and minus, that will become plus, that is 1 upon t plus c. Okay, integral of t raised to minus 1 is minus 1 upon t. Now resubstitute the value of t, and therefore you will get I is equals to 1 upon in bracket 1 minus tan x bracket complete plus c. Now the next question. Next integral is I is equals to integral cos of root x upon root x into dx. Now put here the function root x is present, its derivative is 1 upon 2 times root x. Therefore put root x is equals to t, its derivative is 1 upon 2 root x into dx is equals to dt, and therefore 1 upon root x into dx is equals to 2 dt. Okay, and this is the important part. Now our integral I is equals to integral of cos of root x upon root x into dx is equals to integral root x is t, therefore it is a cos of t dx upon root x, it is 2 dt. Okay, and therefore 2 integral cos of t into dt. Now its integral is a sin of t plus c, and therefore I is equals to 2 sin. Resubstitute the value of t, it is root x plus c. Okay, and therefore the answer I is equals to 2 sin of root x plus c. Okay. Now the next problem. Now here I is equals to integral sin of 2x into cos of 2x into dx. Now what is the substitution? Put function and its a derivative. Put sin of t 2x is equals to t. It's a derivative. That is a 2 times cos of 2x. Derivative of sin of 2x is cos of 2x. Derivative of 2x is 2 into dx is equals to dt. Therefore, cos of 2x into dx is equals to dt upon 2. Therefore, this bracket. Now our integral will change. I is equals to integral in root of sin of 2x into cos of 2x dx. Okay, and this equals to integral root t cos of 2x into dx is dt upon 2, again 1 upon 2 root t into dt. Okay, now the integral of root t, put that t raised to 3 by 2 upon 3 by 2 plus c. This 2 will get cancelled, and here you will get 1 upon 3 t raised to 3 by 2 plus c. Therefore, this substitute the value of t 1 upon 3, okay, in bracket sin of 2x bracket raised to 3 by 2 plus c. Okay, now the next problem. I is equals to integral cos x upon in root of 1 plus sin x into dx. Okay, now what is the substitution here? 1 plus sin x is equals to t. Its a derivative is a cos x. Therefore, put 1 plus sin x is equals to t. Therefore, cos x into dx is equals to dt. Okay. And here we have the one required value. Now our integral I is equals to integral cos x into dx. It is a dt. Therefore, this is a dt upon in root of 1 plus sin x. Therefore, a root of t. Therefore, its integral is e raised to minus 1 upon 2 into dt, and its integral is a t raised to 1 upon 2, okay, upon 1 upon 2 plus c, and this equals to 2 times t raised to 1 upon 2 plus c, okay. That is equals to 2 root of t plus c. This is all. Now resubstitute the value of t. Okay, what is t? T is a 1 plus sin x plus c, and hence I is equals to 2 in root of 1 plus sin x plus c, and this is the answer. You can see this. Very easy questions are here. Next, I is equals to integral cot x into log of sin x into dx. Now here the substitution log of sin x is t. If you differentiate it, you will get cot x. And therefore, by observation, you can select the proper substitution. Put log of sin x is equals to t, and therefore 1 upon sin x, and derivative of sin x is cos x into dx is equals to dt, and therefore cot x into dx is equals to dt. Now our integral I is equals to integral cot x into log of sin x into dx. Cot x into dx is dt, and log of sin x is t. Therefore, t into dt, its integral is e square upon 2 plus c. Okay, and hence I is equals to e square upon 2 plus c. Substitute the value of t, and hence I is equals to log of sin x bracket square upon 2 plus c. This is the answer. Now the next question. I is equals to integral sin x upon 1 plus cos x into dx. Now again here the function is 1 plus cos x. Its derivative is a minus sin x. Okay, we can arrange it. It's a minus sign. Put 1 plus cos x is equals to t. Therefore it's minus sin x into dx is equals to dt, and therefore sin x into dx is equals to minus dt. This is the first part. Okay. Now substitute the value here. I is equals to integral sin x into dx, it is a minus dt, upon 1 plus cos x is a t, minus integral dt upon t. Its integral is a minus log of mod of t plus c. Therefore here I is equals to minus log of mod of t plus c. We can observe this negative sign also, or keep it as it is. I is equals to minus log of, what is the value of t? T is 1 plus cos x plus c. Okay, this is the answer. Now the next problem. Now next problem, I is equals to integral sin x upon 1 plus cos x whole bracket square into dx. Put 1 plus cos x is equals to t. Because the derivative of cos x is a minus sign, we can again arrange that negative sign. Okay, and therefore the derivative of 1 is 0. Derivative of cos x is a minus sin x into dx is equals to dt, and hence sin x into dx is equals to minus dt. Okay, this is the first part. Now the next. What is our integral? Our integral is I is equals to the value of sin x into dx, it is minus dt, upon t square, that is equals to minus t raised to minus 2 into dt Therefore, its integral is a minus t raised to minus 1 upon minus 1 plus c. This minus and minus, that will become plus. Overall, it is 1 upon t plus c. And hence, I is equals to 1 upon t. Means what? 1 plus cos x plus c. Okay. And this is the answer. Always, in each and every problem, there is a function and its a derivative. Very simple substitution for all these problems. If you practice more and more, you can judge what is a proper substitution. Next problem, I is equals to integral dx upon 1 plus cot x. Okay. And this equals to dx upon 1 plus cos x upon sin x. Now simplify this. Integral sin x upon sin x plus cos x into dx. Okay. Now first we arrange here I is equals to three terms like this. 1 upon 2, that is a 2 into sin x, that is multiplied and divided by 2 to the numerator and the denominator. You will get here sin x plus cos x. And to the next step, here 1 upon 2 integral 2 sin x means what? This is the 1 sin x plus cos x, and next the remaining sin x, this is a, and to balance this plus cos x, I will write here minus cos x, and here bracket is completed, and hence this is the sin x plus cos x into dx, and here you will get 1 upon 2 integral. What is that here? Sin x plus cos x upon sin x plus cos x. Next is a sin x minus cos x, sin x minus cos x upon sin x plus cos x, here bracket complete into dx. Okay. Now we can write here 1 upon 2 here sin x plus cos x upon, here you will get 1, and okay 1. Next is a sin x minus cos x upon sin x plus cos x bracket complete into dx. Okay. The integral of 1 upon 2 1 dx plus integral of here 1 upon 2 sin x minus cos x upon sin x plus cos x into dx. Okay. Now the integral of 1, integral of this 1 is x, therefore x plus. Now for this integration, we'll substitute, this is the 1 upon 2 integral sin x minus cos x upon sin x plus cos x into dx. Now to solve this integral, we will substitute, put sin x plus cos x is equals to t. Okay. Then what's its derivative? Cos x minus sin x bracket complete into dx is equals to dt, and therefore this integral can be written as 1 upon 2 x 1 upon 2 integral of sin x minus cos x. Okay, we'll take here negative sign as common, then we'll get here sin x minus cos x into dx is equals to dt. Now substitute this value here, therefore you will get here, okay, therefore sin x minus cos x bracket complete to dx is equals to minus dt. Okay, and there sin x minus cos x is a minus dt upon t. Okay, therefore its integral is 1 upon 2, keep it as it is, and the integral of this minus 1 upon 2 integral of 1 upon t is log of mod of t plus c. Therefore the final answer is I is equals to 1 upon 2 x minus 1 upon 2 log of mod of sin x plus cos x mod complete plus c. Okay. You can see this. Next integration, I is equals to integral dx upon 1 minus tan x. Again it is written as dx upon 1 minus sin x upon cos x, and then simplification. This is the 1 into cos x is cos x minus sin x upon cos x, and that multiplied, it will be the reciprocal. You will get here cos x upon cos x minus sin x into dx. Now adjust one more term, that is multiplied n and d of this integral by 2, same as the previous problem. That is 2 times cos x upon cos x minus sin x into dx. Therefore, here I is equals to 1 upon 2 integral 2 times cos x means what? First of all, cos x. This is the first cos x. One cos x is remaining. Next, we'll write here minus sin x. Then another cos x. And to balance this minus sin x, I will write here plus sin x. Okay. And this whole divided by cos x minus sin x. Sin x into dx. And therefore here 1 upon 2 integral. If we split off cos x minus sin x upon cos x minus sin x plus cos x plus sin x, and this divided by cos x minus sin x into dx, and hence you will get here 1 upon 2 integral of, this is the 1, plus cos x plus sin x upon cos x minus sin x, bracket complete into dx, and that's equals to 1 upon 2 integral of 1 dx plus integral of cos x plus sin x upon cos x minus sin x into dx. Okay, and therefore it is a 1 upon 2 integral of 1 is a x, and the integral of this we have cos x minus sin x, and this divided by plus cos x minus sin x into dx. For this integral, we substitute put cos x minus sin x, and that's equals to t. It implies that the derivative of cos x is minus sin x is minus cos x into dx, and that's equals to dt. Take minus sign as a common. Sin x plus cos x into dx is equals to dt, and this implies that sin x plus cos x into dx, and that's equals to minus dt. means the value of cos x plus sin x into dx is minus dt. Therefore, this our integral will change 1 upon 2 x plus integral of what is here minus dt upon t, and that's equals to 1 upon 2 x minus log of mod of t plus c. Okay, and finally we write the answer. I is equals to 1 upon 2 x minus 1 upon 2 log of mod of what is a t here? T is a cos x minus sin x plus c, and this is the answer. Okay, therefore you can see this. Now the next problem. I is equals to integral root of tan x upon sin x into cos x into dx. And for this type of integration, we multiplied to the denominator and divide to the denominator by cos x. See this here. In root of tan x divided by what is the denominator? Sin x into cos x. Multiply the denominator by cos x and divide the denominator by cos x into the dx. Then what you are getting? Integral root of tan x upon sin x upon cos x. Here you will get tan x. Cos x into cos x, you will get here cos square x into dx. Again, integral root of tan x upon this tan x, and overall you will get to the denominator root of tan x. Okay, and this 1 upon cos square means what? Sec square x. We write here sec square x upon root of tan x into dx. Now the substitution. What is the substitution here? Put tan of x is equals to t, and it implies that it's a derivative sec square x into dx is equals to dt. Okay, this is that is sec square x into dx is equals to dt. Here the sec square x into dx is equals to dt. Okay, sec square x into dx is equals to dt. Therefore, I is equals to integral sec square x into dx, this is the dt, upon root of t, and that is equals to, now the integral of root of t that is integral of t raised to minus 1 upon 2 into dt, t raised to 1 upon 2 upon 1 upon 2 plus c, and hence here you get I is equals to 2 root of t plus c, and hence I is equals to 2 in root of tan x. Okay, in root of tan x plus c equals to 2 times in root of tan x plus c, and this is the answer. Okay, now the next problem. Next problem is 1 plus log x bracket square upon x. Okay, again here I is equals to integral in bracket 1 plus log x bracket square upon x into dx. Put 1 plus log x is equals to t, and therefore derivative of 1 is 0, log of x is 1 upon x into dx is equals to dt. Okay. And therefore our integral becomes I is equals to integral 1 plus log x is t, dx upon x, it is a dt, and it's very 1 plus log x, it's a square. And what is the integral of t square? It is a t raised to 3 upon 3 plus c. Therefore I is equals to t raised to 3 upon 3 plus c. Substitute the value of this t. The value of t is in bracket 1 plus log x bracket raised to 3 upon 3 plus c. Okay, now the answer. Okay, now the next problem. Now the next problem is I is equals to integral x plus 1 upon x into in bracket x plus log x bracket square into dx. Again the substitution here, this is the function x plus log x. Here put x plus log x is equals to t, therefore derivative of x is 1, log of x is 1 upon x, here bracket is completed, into dx is equals to dt. If we simplify this, then you will get x plus 1 upon x bracket complete into dx is equals to dt. Okay, this is x plus 1 upon x into dx is equals to dt. Here. Now substitute the value. Yeah. Therefore, our integral I is equals to x plus 1 upon x into dx is dt. X plus log x is a t. It is a t square into dt. its integral is e raised to 3 upon 3 plus c, and hence here I is equals to, what is the value of t? T is x plus log x, x plus log x, bracket raised to 3, and this whole divided by 3 plus c. Okay, and this is the answer. X plus log x, bracket raised to 3 upon 3. This is the answer. Now next problem. Now the next problem is I is equals to integral x cube sine of, in bracket, tan inverse of x raised to 4 upon 1 plus x raised to 8 into dx. Okay. Now here the substitution is important. Tan inverse of x raised to 4 is t. Therefore I will write here, put tan inverse of x raised to 4 is equals to t, and therefore it's a derivative 1 upon 1 plus x raised to 4, it's a bracket square, into ddx of x raised to 4. Okay, or we'll directly write here, it's a derivative. What's its a derivative? Its a derivative is 4x cube into dx is equals to dt. Therefore x cube into dx upon 1 plus x raised to 8. Okay, transfer this 4 to the right hand side and it will become dt upon 4. This is important. X raised to 3 into dx upon 1 plus x raised to 8 is equals to dt by 4. And this is the important. Therefore our integral, this can be written as x cube dx upon 1 plus x raised to 8, that is a dt by 4, and this is a t. So therefore sin t into dt by 4, that is equals to minus cos t upon 4 plus c. Okay, and therefore I is equals to minus cos of tan inverse of x raised to 4 upon 4 plus c. Okay. This is the answer. Okay. Answer is. Now the next type of problem. Now the next question number 38. Choose the correct answer in exercise. That is a 38 and 39. Okay. For the examples, integral 10 into x raised to 9 plus 10 raised to x log of 10 to the base c into dx upon x raised to 10 plus 10 raised to x is equals to. Okay, it's clear that the in optional a, b, c. There is no log. Only the log is present here, and it is the log of 10 raised to x plus x raised to 10. Because here is a f dash of x upon f of x. Its integral is a log of f of x. Okay. But how it is, we will solve these examples with the step by step. Put x raised to 10 plus 10 raised to x is equals to t. Therefore 10 x raised to 9 log of 10 raised to x is 10 raised to x into log of 10, here is a bracket complete, into dx is equals to dt. Okay. Now see this here, 10 into x raised to 9, 10 raised to x into log of 10 bracket complete into dx. This is nothing but the dt, and therefore the integral, okay, this integral is a dt upon t. Its integral is a log of mod of t plus c, and hence I is equals to log of mod of t. But what is a t? T is a x raised to 10 plus 10 raised to x plus c, and hence the option D is a correct one. Now the next multiple choice. Now the next integral, dx upon sin square x into cos square x. We'll solve this. I is equals to integral dx upon sin square x into cos square x. Okay. Therefore, here the integral is dx upon sin square x. We consider here is as 1, and what is a 1? 1 means cos square x plus sin square x bracket complete, and this whole divided by sin square x into cos square x into dx. Now split up this. We split up this cos square x upon sin square x into cos square x. Cos get cancelled, and in bracket you will get 1 upon sin square x plus again sin square x upon sin square into cos square x. Sin get cancelled. You will get 1 upon cos square x. This bracket is completed. And next, what is the reciprocal of sin square x? 1 upon sin square x is a cos x square x. Okay, this is the cos x square x, and 1 upon cos square x is a sec square x. The integral of these are very easy. The integral of cos x square is minus cot x, and integral of sec square is a tan x plus c, and again this can be written as the first term as a tan x minus cot x plus c. And where is a tan x minus cot x plus c? The optional P is a correct one. And in this way, we have completed this biggest video, that is for the exercise 7.2 methods of substitution. Now we'll see in the next video. Till then, goodbye.